Acid and bases theories. In acid and bases theories in chemistry classes, the chemistry class that we have now, we have two theories that we are going to learn. We have Arrhenius theories, and we have also Bronsted and Lowry theory. Arrhenius was the first to introduce his theory. Arrhenius said, an acid, so the definition of acid theory. According to Arrhenius, so Arrhenius, I'm going to write here, Arrhenius theory of acid. So, according to Arrhenius, an acid is a substance, any substance that dissociates in aqueous solution to give H plus ion. So, according to Arrhenius, as I said, an acid is any substance that dissociates in water to give H plus ion. Okay, this is the definition of acid according to Arrhenius. So, Arrhenius, acid dissociate in water to release or to produce H plus ion. So acids dissociate in water to produce H plus ion. And he said, according to bases, so the basis for him, for Arrhenius, the bases are substances that dissociate in water to produce OH ion. So dissociate in water to produce OH ion. So this is the theory, Arrhenius theory of acid and base. And then after him, there was a guy called Bronsted. But Bronsted was not alone. He had also his friend, Lowry. So Bronsted and Lowry, they introduced, so Bronsted so let me see the spelling, let me check the spelling. Yes, Bronsted and Lowry. So Bronsted and Lowry theory, for them, for Bronsted and Lowry, they say no. Acid is any substance. It is any distance that is proton donor. Okay? So acid are proton donor. Proton donors. So acids are proton donors. And the base are proton acceptor. Proton acceptor. So it was for them, it is very simple. Proton donor, proton acceptor. This is the definition for them. So they, in the definition, if we can look properly, and the definition of acid and base according to Arrhenius, there is something that is wrong. And it was, the theory was criticized by Bronsted and Lowry. They say, oh, what you say there, okay, we accept, but it's not, it is not totally right. Because they are also the solution, there are reactions that occur in any other solvent than in water. So we cannot always say dissociate in water. Okay, because we have other solvent. Apart water, we have also other solvent. Okay, we have, for example, the hexane is also a solvent. Hexane is also a solvent. There are also reactions that happen in solvent, in hexane, for example, as a solvent. So we cannot limit our definition only to water. No. So this is the first limitation of Arrhenius theory. The first limitation, that it's limited to water only. But what about outside of water? When we have an example, say hydrogen plus chloride, hydrogen gas and chloride gases, there are two gases, they don't react only in water. No, there are gases that can react out of water to give hydrogen chloride. Okay, this it is a gas, and this is also a gas. So they react to give hydrogen chloride.
Yeah.
This is also a gas. Okay, so this is they show that this is your limitation.
Yeah.
Okay, and the two limitations that we have there. If we take, for example, according to Arrhenius and Arrhenius from theory of acid, if you consider, for example, if we consider, for example, if you consider this, for example, and then it dissociate to give yeah. So this they can dissociate to give that. And another thing that we need to know is that, okay, I gave you two limitations. The first limitation, I said, it is not, the reaction doesn't happen only in water. Okay, it's what I said. It doesn't not happen only in water, it happens also out of water. A second limitation, what we said?
That it only becomes like an acid if it's in water.
Sorry?
like it only works in water.
Yeah. Okay. Now, another limitation that we can say, that in water, if it happens in water, okay, the ion that is released is not only, it is not H plus. Okay, they criticize him. It is hydronium ion. Okay, it is hydronium ion. So if this is in water, we have hydronium ion that is released. This we go to give what? Okay, so we have this nitrate acid in water. Okay, nitrate acid in water. We have hydronium ion. This is hydronium ion plus nitrate ion. Okay, so now we are going to this part of the class. This is the theory, and we are going to get the question. The questions, I'm going to look for the questions here that we are going to answer. Okay? Now,